So going over Wildcat sheet 1. Number 1 says convert this number to scientific notation. Okay, well, scientific notation looks like how we've got it set up in number 2. I need to have one number in front of the decimal place. So one real number, that would be the 1. So my decimal is going to be in between the 1 and the 3. So I move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. I copy down everything after the decimal. So I have 1.302. It's always times 10 to the. I moved the decimal 11 times, but originally this was a really, really small number. So it's 10 to the negative 11. If it was a really large number, the exponent would be positive. Now it wants this scientific notation number converted to standard form. Well, my exponent in this case is positive. So I'm going to move my decimal 6 places, 1, 2, 3, 4, 5, 6 to the right, fill in with zeros. So my final answer is 4,012,000. Okay. Number 3, find the square root of 196. Well, this one should be one of the easiest questions because I'm literally just entering it in the calculator. To get the square root, we're going to hit second, which is the blue button, x squared, type in 196, and I get 14. Now remember, square roots can either be positive or negative, so it's plus minus 14. Number 4 says find the square root of 676. So again, second, x squared, 676, I get 26, and square roots can be positive or negative, so plus minus 26. It says, the next one says order the following numbers from least to greatest. So we want to put all of our numbers in decimal form. So 3.5 as a decimal is 3.5. And then I can do the square root of 12 in the calculator. Second, x squared, type in 12, hit enter. Then we have 3.46. Going out to the hundreds place should be fine. Pi is 3.14. And then I can do the square root of 30 divided by 2. Well, first do the square root of 30. Second, x squared, type in 30. Now I've got my number here. If I just hit the divide symbol and then type in 2, see how it says answer divided by 2? It's going to take this number and divide it by 2. And I get 2.74. 2.74 after I round because the 8 tells the 3 to bump up. And then least to greatest. Well, 2.74 is the smallest, so the square root of 30 divided by 2 is the smallest. Then we have pi, then the square root of 12, and then 3 1/2. It's always easier to convert them to decimals and then go back and order them. The next question says select all real number classifications that apply to the following number. Well, first you need to simplify. Before I can do anything, I got to simplify this. So I'm going to do the square root of 36 and divide it by 3. So I get 2. So if I'm talking about the number 2, it can be a natural number because I can count to 2. Natural numbers are also whole numbers. Whole numbers are also integers. Integers are also rational. Well, if it's rational, it cannot be irrational. Remember, irrational numbers are numbers like pi. They're decimals that go on forever and never repeat. And every single number I know is a real number. Number 5, what transformations preserve congruence and orientation? Okay, well, we're going to pretend my hand is an object on the coordinate plane. If I translate it, I just slide it over. I did not change the size of my hand. I did not change the way my thumb is pointing. That's the orientation and the congruence. So translations preserve it. Translations. Again, my hand is the object on the coordinate plane. If I reflect it, flip it over, I didn't change the size of my hand, but I did change the direction my thumb is pointing. So reflections do not preserve orientation, even though they preserve congruence. And lastly, dilation, I have dilations, which makes my hand bigger, so that does not preserve congruence. And if I rotate it, I'm not changing the size of my hand, and I'm actually not changing the way it's pointing because I'm just moving the whole object. So rotations preserve congruence and orientation as well. Number 8, to find a new area after dilation, you must multiply the old area by the scale factor squared. Scale factor squared to go from the old area to the new area. Remember, area, our units are squared. Therefore, when we're finding the new area, we got to square our scale factor. Okay, a triangle is translated 3 units horizontally and -2 units vertically. Write the rule of transformation. So all of our rules start x comma y. We have an arrow. And then I got to fill in the rest of the ordered pair. Well, horizontally, when I move from left to right, that's horizontal. So that's movement in the x. It's a +3, so I'm going to say x plus 3. Vertical is movement in the y, and it is -2. So here we go. We have -2 or y minus 2. This is the rule of the translation. A pentagon is enlarged on the coordinate plane. Which of the following could represent the rule of dilation? Okay, to be enlarged, my scale factor has to be greater than 1. So I'm going to make these fractions both decimals. To do that, you divide the numerator by the denominator. 5 divided by 4 is 1.25. That looks like a good candidate because our scale factor is greater than 1. And then we have 3 divided by 5. Well, that's 0.6. That's not greater than 1. A is the only option. Number 11, find the missing side length. Okay, we have 2 similar triangles. We can tell that by the angle theorem. Here we go. So we're going to set up a proportion. I want to find x, and x is on the same shape as 16. So here we go. 16 is this side right here touching the angle with the 2 circles. So 16 matches up with 24. So I'm going to put 24 on the top. And then 21 and x are between the 2 angles that we have marked. So 21 is going to be on the same line as x. I cannot go from 24 to 16, but I can simplify 21 and 24. I can divide them both by 3. 24 divided by 3 is 8. 21 divided by 3 is 7. 8 times 2 is 16. So on the bottom, I'm going to do 7 times 2. So x is equal to 14. Number 12, rotate the following image 90 degrees clockwise. Well, 90 degrees clockwise is 1 turn of the paper to the left. After I make that turn, the top left corner is now quadrant 1. This is quadrant 2, quadrant 3, and we have quadrant 4. And all I'm going to do is write down the points of our new, write down the ordered pairs of our new points. So here we go. A prime. A, I go 3 positive and up 2. So we're going to do 3, 2. B, I go 1 to the right, 3 up. So B prime is 1, positive 3. C, I go 1 to the right, 1 up. So C prime is 1, 1. Now I rotate my paper back to the original position, and I just plot these points. So we have 3, 2, 3, 2. That's A prime. We have 1, 3. That's B prime. 1, 1, C prime. I now have rotated my triangle 90 degrees clockwise. Number 13, a flagpole casts a shadow of 36 feet. When Patrick, who is 6 feet tall, stands in front of the flagpole, his shadow is 18 feet long. How tall is the flagpole? Okay, so here we go. We have our flagpole casting a shadow. The flagpole is 36. We have Patrick, who is 6 feet. His shadow is 18. This must be x. So if I set up a proportion, Patrick is height to shadow. Then we have the flagpole's height to its shadow. Well, to go from 6 to 36, I multiply by 6. 18 times 6, I can enter that in the calculator. 18 times 6 is 108. So the flagpole shadow is 108 feet. Okay. The slope of PV. Okay, PV is our diagonal line we have here. So the point of P is 2, 4. And the point of V is 3, 0. So there are 2 ways to do this. I can either do rise over run. And when I rise, I go down 4. And I go right 1. So -4 over 1. Or I can make an XY table and find the change in Y over change in X. So we have 2, 4, 3, 0. I subtract 4. I add 1. Again, -4 over 1, which my slope is just -4. Write an equation that describes the rate at which the hot air balloon rises during a flight. Okay, so I have a table here. We can use those points and enter it in linear regression, and it will write the equation for us. So I'm going to clear my calculator first. Seconds plus 712. And now I'm going to hit stat, enter. I'm going to enter my X values in list 1. So 10, 20, 30, 40, 50. And then I'm going to enter my Y values in list 2. We have 40, 80, 120, 160, 200. And now I'm going to hit stat again, right arrow over to calc, hit 4, enter until the screen changes. And now I have my equation. We have y is equal to 4x. I don't really have to put the plus 0 because it is just 0. Number 16, the cost for electricity varies directly with the amount of kilowatt hours of electricity used. The cost for using 1,079 kilowatt hours of electricity was $129.48. What was the cost for using 908 kilowatt hours of electricity? Okay, when we say varies directly, I can set up a proportion. So we have 1,079 over $129.48 is equal to 908 over x. When we have a proportion, we can do what's called cross multiply. So 1,079x is equal to, going to multiply 908 times 129.48, which gets me 117567.84. Okay, and then I just divide by 1,079, which is $108.96. Is the following graph a function, y or y not? Now, obviously, I wrote over this, so it's a little bit hard to see, but it is not a function, not because the line disconnects, but because there are two x values. The x is repeated. So we have -1, 1, and we also have -1, -1 as points on this graph. So it is not a function because x repeats. Not a function because x repeats. Okay, number 18, I'm going to need some more space for, so I'm going to use my scratch piece of paper. Number 18 says the perimeter of a triangle is equivalent to the perimeter of a square. What is the value of x? So this is a square. This is also 2.5x, 2.5x, 2.5x for the side lengths. So the perimeter of a triangle, I'm going to add 2x plus 4x minus 2 plus 2 times x plus 7 is equal to, there are 4 sides that are 2.5x, so I'm going to say 4 times 2.5x. All right, the first thing I'm going to do is distribute. There's nothing to distribute here, so I can basically ignore the parentheses, but I can distribute my 2. So 2 times x is 2x, 2 times 7 is 14, and I bring everything else on this side down. We have 4x minus 2 plus 2x. I can also distribute on this side. I have 4 times 2.5x. Well, if I, in my calculator, I do 4 times 2.5, 4 times 2.5, I get 10, so this is 10x. Now, on the left side of the equation, I can combine like terms. So I have 2x plus 4x plus 2x. 2x plus 4x is 6x, plus 2x is 8x. Bring everything else down. We don't want to do too much at one time. Now, I can still combine -2 plus 14. Well, -2 plus 14 is 12, so I have 8x plus 12 is equal to 10x. I want to move the variable, so I'm going to move my smaller variable. I'm going to subtract 8x from both sides. I get 12 is equal to 2x. Divide by 2, divide by 2. 6 is equal to x. So for our question number 18, x is equal to 6. All you have to do is set all the perimeters equal. What is the value of z and what is the value of w? Well, if we know by our exterior angle theorem that this w is equal to 45 plus 60 added together. So if I add 45 plus 60, I get 105. So this is 105 degrees. Since z and w make a straight line, they total 180. So I can do 180 minus 105 and get that z is 75 degrees. Number 20, which transformation rule does not preserve congruence? Well, if I don't preserve congruence, it means I'm changing the size of the object. To do that, we're talking about a dilation. And dilation means to multiply. So I'm looking for one of these that has multiply, and the only one that has multiply is A. 21, what transformation or a figure was transformed on the coordinate grid using the rule xy becomes negative x, negative y based on the rule what transformation occurred? When the letters are in the same spot and they are both negative, it is a 180-degree rotation. It does not matter which direction you move, it will be the same. 22, the fallen triangle was reflected over the y-axis. What is the coordinate of J? Okay, so if I reflect this over the y-axis, I'm just flipping it over here because this is our y, our vertical line. J is currently at 4, 7. So when I reflect over the y-axis, I'm just changing my x value to be negative 4, 7. So that is J prime. You can even notice it's the same distance away from the y-axis. This is 1, 2, 3, 4. This is 1, 2, 3, 4. All right, a preschool has a rectangular field, each rectangular playground, and a rectangular playground that is the same shit. Let me start that sentence over. A preschool has a rectangular field and a rectangular playground that are similar in shape. Each dimension of the field is 3.2 times the corresponding dimension of the playground. Which statement is true? The area of the field is 6.4 times larger than the area of the playground. Okay, if I'm talking about area and we're talking about similar shapes or a dilation, area is always going to be your scale factor squared. So I need to figure out what 3.2 squared is so that I'll be able to answer this. So we're going to do 3.2 x squared. 3.2 x squared, which is 10.24. So I need to change the area by 10.24. The perimeter only changes by the scale factor. The area changes by the scale factor squared. Number 24, solve for x. Well, first thing I'm going to do is rewrite all subtraction as adding a negative to make sure I don't mess up my signs. And then I'm going to distribute. Negative 2 times x is negative 2x. Negative 2 times negative 3 is a positive 6. Bring down everything else. Combine like terms on the left side if I can. I can add 6 and 5, so I get negative 2x plus 11 is equal to negative 37. There's nothing else I can combine. There's not a variable on this side, so I'm going to go straight to adding and subtracting. Subtract 11 from both sides. That goes away. I'm left with negative 2x is equal to, well, negative 37 minus 11 is negative 48. Divide both sides by negative 2. X is equal to 24. And lastly, solve for x. Okay, this is our transversal. I'm going to turn this on its side. These are our two parallel lines. Here is our transversal. I can see that both of these angles are outside the parallel lines, and they are on opposite sides of the transversal. So they are alternate interior angles. They're alternate interior angles. And alternate interior angles are equal or congruent, so I'm going to say 70 is equal to x plus 16. Subtract 16 from both sides to solve for x. So 54 is equal to x. All right, this should have covered all of your Wildcat Sheet 1. Please make sure you make all your corrections.